Good morning, everyone. In the previous class, we have started discussing this Unix process. We'll recap some of the topics that we have discussed, and then we'll continue with our the next topics. See that we have started with the main functions. So this main functions we have already seen in the C program. The same main function which has a two arguments. One will be the number of the command line arguments. The another one will be the array of pointers to the arguments. By passing the index to that, it is a character array. By passing the index to that, you can get the values which are passed in the command line. And this main functions why we are discussing here is the most of the Unix operating system. It has been designed using the C language. Uh, then the C program usually it will be the main function will be written in that. That is why we have discussing here the main functions. Who will call the main function is the question. The main function will be called by a special routine, which is called as a special startup routine. This startup routine will be called by the kernel. The kernel is going to call the startup routine, and that startup routine is going to call the main function. The main function, if it requires the command line arguments, who will pass? The startup routine is going to pass the values. How the startup routine will get, the kernel will provide. This is how the process goes. Uh, any program is under the execution is needs to terminate. It can be a normal termination or abnormal termination. Normal termination is possible with the one possible case is written from the main. From the main, all the instructions are executed. You have included a return statement, then it will stop. Or there are exit function. There are two types of exit function: exit and underscore exit function. Those exit functions, if you use, then also the program under execution will terminate. One more is abnormal termination. Abnormal termination is some interrupts or any other unusual situation has happened and abort function is called. In that case, it is called as a abnormal termination. Finally, what happens is the process will terminate. Still, other so many ways the process can terminate with the threads can terminate by calling the exit functions. You have seen these two exit and underscore exit. What is the main difference is the exit function will perform some cleanup process before it terminates. Whether if the values are to be stored, it has to keep the backup or to store somewhere. It is going to do any garbage collection, freeing up the memory or freeing up the resources. That is called as a cleanup processing. All these function will be done, then the control will go back to the kernel. But if you use the underscore exit, it is like a fast food. Quickly, it is going to return the control to the kernel immediately. The program under execution will terminate. It will not do the cleanup process. That is the main difference between these two, exit and then underscore exit. There is one more function called at exit. This at exit function is many of, if you want to register some functions, register some functions, those functions, it has to be executed after you call the exit function. From the during the normal execution, you want to terminate. Some situation has happened, you want to terminate. Then you are going to call exit function. After when you call the exit function, you have to do something that some work that you have stored in the functions. They are called as the exit handlers. Those exit handlers, there can be any number of exit handlers. It is not mandatory all the functions you execute. Assume that there are some 50 functions. In that 50 functions, you want to execute some 10 functions. After the exit function has executed, then those 10 functions, it has to register. In order to register, you have to use this function called at exit. To at exit, you have to give the function name. In which order you have registered, in the reverse order, all those functions will be executed. How many times you register, those many times that function will be called. For that, we have seen this example. See, at exit function is there. My exit 1, my exit 2, they are the function names. They are the function names. How many times? This is how you are going to register. At exit of my exit 2, at exit of my, this is how you are going to register. The return value, if it is equal to 0, it has properly registered. If it is not equal to 0, the error happens. See, two times you have registered my underscore exit. That is why what happens? uh, Two times the my exit one printf is going to print. The content of that is first exit handler. That is why two times first exit handler will print. After that, second exit handler. See, the output when you check of this program, it will be, this will be the first output. Main is done. Main is done. After that, return statement is there. Return statement is equal to the exit of 0. You can write like this, return of 0 or exit of 0. Then the program will terminate. When the program terminates, I said the registered functions will be called. Which are the registered functions? These three. That is why main is done, first exit, first exit handler, then second exit handler in the reverse order. Reverse order it will print. Next is the command line arguments. The command line arguments, as I said, you can directly fetch the values inside the main functions. How? Just by giving the index, by giving the format specifier. Argument C will contains the count of the number of arguments. That no need to provide, automatically it will count it. If you give the index to that, you will get those values. This you already know. And also the environment list. Yesterday I have shown you the environment variables are there. If they are required inside the program, this environment list you can directly pass. It has a third argument. You can directly pass it as a third argument after this main function. This two arguments. After that, the list of environment you can pass it. How it will be stored? See, environment variable, usually the syntax of that will be name equals value. Here, whenever you store in the environment list, those address value will be the address. That should be ended with the null string. These values, it will be stored in the environment list. The pointer of that you are going to pass it as a third argument in the main function. What is the use? That values, if you want to use it in the programs, you can directly use it if necessary. Directly these values will be not be passed. The address of that will be passed. Character star star environment. Why it is two stars? Because the address of this will be get it in the environment list. That address will be stored in this variable. That is why two stars. Then next topic will come to the memory layout of the C program. See, we know two types of memory. One is primary memory, another one is secondary memory. We'll not discuss about the secondary memory hard disk. Primary memory RAM that we are discussing. For a C program, whenever you execute the C program, how exactly it will be executed inside the memory? Memory, when you check how the space size is been allocated. The memory, it will be divided into so many parts. There were some addresses will be given for text segment. Some address will be given for text segment. The second part will be given for data segment. I'll show it in the text. This is how it looks. If the typical memory, it is not directly a RAM. The some part of that we are showing it here. Some addresses will be given for test segment. Test segment is nothing but code segment. The next part is for data segment, means values. There will be a stack, there will be a heap space, and then for the command line argument. See, lower addresses, higher addresses, means the addresses will increase. It is not a complete uh, uh, memory. The part of that for the execution of the C program, we are demonstrating just only that layout. What exactly it will store in the text segment? It is the code. Code is nothing but machine instructions, not the C program, the higher language. It is the machine instruction. The machine instruction will be copied into the text segment. Why we are going to copy? Because the CPU is going to execute that. Only that copy will be stored in the that text segment, or it is called as the code segment. Once it will be copied, the mode of that will be changed to read only, because the other program should not overwrite that content of that machine instructions. And also it is shareable. That code, it is shareable and it will be in the read only mode until the CPU executes. The next segment will be the data segments. Two types of data segments are there, initialized and uninitialized. Uninitialized is, we have seen in the C program, in the beginning we write some integer array in the bracket 100 semicolon. By default, it will be empty. The value will not be stored. It will be initialized to 0 or null values. If those variables are there in the C program, for that, memory allocation will be done in the uninitialized data segment. Whenever you store the value in those location, it will be directly moved to the initialized data segment. If you initialize the values in that will be stored in the initialized data segment. If the values will be initialized to 0 or null values, then that will be stored in the uninitialized data segment. Data segment usually is for data, which is the values which are there that you have used in the C program. The stack and the heap, this you already know. This is a part of the memory where the stack stores the return addresses and the information about the calling environment. See, from the main function, we are going to the other user defined functions. From the main, you have moved to the one more function, but if you want to come back to the main once again, where exactly the return address will be stored, the return addresses will be stored in the stack itself. How the recursive functions will work? The recursive functions will work because of this stack. Without this stack, the recursive function will not work, because multiple times the same function will be called. There, the addresses of the return call that will be stored in the stack. One more memory is this heap. Heap is nothing but it is a dynamic memory allocation. Dynamic memory is during the program execution, you require some space. The execution has started, but you require some 1000 bytes. That we don't know in the beginning itself. When the program was written, that we don't know. That is why we have not allocated that 1000 bytes. But the user has entered those some values. In that situation, during the execution, you require some space. In that case, what we do is we are going to allocate dynamically that space. It will be taken from the heap part. There will be a space, that we call it as a heap. That is why it is called as dynamic memory allocation. That is all about the memory layout. The next we will discuss about the shared libraries. See, the libraries is nothing but a set of programs, set of informations that is been already stored, that will come up with the operating system itself. Whenever we execute our programs, that will directly fetch those libraries and execute the functions. What is the problem, or what is the if we don't use this shared libraries, what is the problem is, I'll show it here with the example. See, some C program is there, memory allocation. Some, don't worry about the content of this. Some C program is there. I'll execute this function. How to compile the program? It is cc hyphen static memory allocation dot c. See the size. See that there is a function called size. The size will give you how much size the test segment, the data segment, uninitialized, this is initialized, uninitialized data segment as used. That you are going to get it from the function called size. Yes. See here some 5 lakh bytes. Data segment 1928 bytes. Uninitialized data segment 7 almost 7,000 bytes. See this much of space it has taken for this memory allocation.c. Why? During the execution of this program, this function has kept the one copy of library with this program execution. Means it has moved the library into the memory. The one copy of the library, the set of programs, it has moved to the memory for the execution of this. That is why it has taken so much of space. Instead of that, if we use the shared library, the entire copy of the library, it is not required to move to the memory for each program execution. For that, what we do is, see now, if we use the shared library, see now the space, it is just only 1800, 272, 8 bytes. If you use this, the static, then for each program execution, it can be any file. Here I have written only one C file. For each C program's execution, it will maintain the one copy. It will copy the entire library into the memory. It executes. But if you don't use that, if you use the shared library, then what happens is the same library will be fetched and it is going to execute. What is the advantage is it reduces the size of the executable file. If you use the shared library, the size of the executable file is reduced. See, it is the shared library concept is already those library routines are there in the operating system. Whether to keep a single copy in the memory for the process reference or multiple copies for each program execution. That is all the difference. During the execution, if you use the shared copy, some runtime overhead will be there. But more than that, the executable size is reduced. That is the main advantage. The next part is The memory allocation. This concept, this memory allocation that you have already studied in the data structure, the same topic. What is malloc, alloc, realloc, and free space? The malloc is, see, since we are discussing the heap means, we are going to discuss about this memory allocation. The malloc is allocates the specified number of bytes of memory. Calloc is, it allocates a specified number of objects, those many specified number of blocks of specified size. Realloc is some space you have allocated, but you have to change the size of the previous allocated, then you have to use realloc. One more command is free. Free is nothing but memory has been allocated, but you have to deallocate. It is not at all required. Free up the space. With the figure, then you can easily understand. See the malloc. The syntax is this: malloc. An example is 5 into size of the hint. The size of the hint is 4 bytes. To the malloc, if I pass the size of the 5 int, I require 20 bytes. I require 20 bytes. I want to store the some integer values. In that case, what we are going to do? 5 into size of the int, if I give 20 continuous 20 bytes of memory is been allocated, the address of this will be the return type, means the pointer. The next one is Kellogg. See the Kellogg, you have to give the number of blocks required of this size. In this example, I have given 5, means 5 blocks of what size? 4 bytes. 5 comma size of the int. Totally it is a 20 bytes of memory, but 5 blocks of uh, each of 4 bytes. That is the main difference between this malloc and calloc. The initial address will be given to this pointer. The main difference between this malloc and calloc is, here it is a single block of memory, here it is number of blocks we are going to specify with this size. Freeing up the space. Freeing up the space means you have already allocated the memory. You are using the calloc, you have allocated the memory. If you give this address, this pointer variable to the function called free of this pointer, it is going to free up that space. Those addresses will be available for next malloc and calloc functions. For next malloc and calloc functions, those addresses will be free. You can use it. If you don't use this free, still that will be allocated with some garbage values or some the user values. You cannot use it. That is why whenever you use this malloc and calloc, you have to free up the space at the end. Realloc. Realloc is, see, you have used the malloc function, 20 bytes of memory you have allocated, but now you want to increase the size. That is why the, the malloc function pointer, you have to pass it as a first argument to the realloc. After that, how much extra size is required, that you have to pass it as the second parameter. First parameter is already allocated memory address you have to give, that is this pointer, comma, second value will be how much extra size is required. I require another 40 bytes. Another 40 bytes is some 10 into 4. Totally 40 bytes of memory is been will be changed. This will be the new size. Whenever you give this pointer, whatever is the second pointer, that will be the new size. Initially it was 30. Now I have given 10 into 4. Size of the int is 4. Now it has changed to 40 bytes. Reallocate means reallocate the dynamic memory. Reallocate is not always to increase. Even you can decrease the size of the previous allocated memory. That is the advantages. This is the syntax of that. Still, uh, the Unix operating system will provide so many other functions like valloc, JEalloc, just to allocate the dynamically allocation memory. Still, there are so many other dynamic memory allocation functions are there, but most of the time we are going to use this malloc, calloc, and realloc. That is all about this memory allocation. So that is not new to you, that you have already seen those functions in the data structure. Now we'll move to the environment variables. We have seen the environment list, the same what we are seeing it here, environment variables. See, what is this environment variable is? Environment list what you have seen, the content of that will be the environment strings. Those environment variable syntax will be name equals value. The Unix operating system has provided the function itself to get the values of the environment variable. Instead of directly you pass in the command line argument as a third argument, instead of that, you can directly use the function itself. Get the environment variable, put the environment variable, set the environment variable, or unset the environment variable. See, what is this get environment variable is already inbuilt, the value is been stored. Just you give the name, get the value of that with this function, get environment variable, which is an environment variable like this. I'll show it here. Echo dollar path. See, this is one environment variable, another environment variable. See, this is the name and this is the value. In order to get the value, you can directly use this function. Get environment, sorry, you give the name $path home, you will get the pointer to that value. See, that is why here it is character star. You will get the address of that value. From there you can get the value of that. One more is put environment. Put environment is for the first time you are storing the environment variable or a new environment variable you are going to add. In that case, you have to pass the string in the form name equals value. You have to give in this form itself. Name equals value, that you have to pass it to the this put environment, that will store a new environment variable in your system. Then after that, once again with the get environment variable, you can get it. Next, instead of this put environment variable, see, one more thing is, if this already exists, if it's already exists, it is going to overwrite. Remember this, put environment, if already an old copy is there, it is going to overwrite. But set environment, some extra facility is there. You have can directly pass the name, you can directly pass the value, second parameter. Third one is you have to give some integer value, whether you want to overwrite or not. The non-zero value 1, if you give, it indicates that you have to overwrite. If you directly pass 0, the third value, it indicates don't overwrite, keep as it is. Previously some value is there, keep as it is. That is the meaning of rewrite. Non-zero value, non-zero value means overwrite 1 if I pass. 0 means don't overwrite, means it is going to neglect whatever you pass. If it wants to overwrite, then you have to pass non-zero value. Unset means, see, this one you have already stored, this path and home, you have to remove it. You have to delete this environment variable. If you want to delete that environment variable, you can use unset environment. Then if that name is there, it is going to remove that, or else it will throw you the error. That is the syntax of this environment variable. Get is to get the value. Put is to put both name and value. Set is to give both the name and value, but with the rewrite condition, overwrite or not. Unset means to remove those environment variable. Whenever here there is one problem. One thing is, whenever you store the environment variable, whenever you want to change it, there is a function called set function is there, right? Set function is there. If you want to overwrite, see here, the path variable, the length of this path is so much, this much of size. But the home, it is only this much. If you want to change this, in the background, there should be a memory allocation. You have to increase the size of this. Whenever you want to increase the size, it should be dynamically you have to do. Dynamically means whenever you want to change, you have to use this dynamic memory allocation function, and then you have to change it. That is some extra thing that you have to do. It is directly you cannot do the set function, set environment function. You have to use the dynamic memory allocation, and then when the situation occurs is the value, the new value that you want to overwrite compared to the old value, if it is larger size, then you have to use this malloc function and then extend the size and then place the new value. If the older value is bigger, larger, then the new value which you want to overwrite, then that is not a problem. And also, see here, the so many environment variables, it is not at all supported in all the different flavors of Unix. POSIX, FreeBSD, Linux, Mac OS, Solaris. See, in Linux 3.2.0, all these functions are supported. In FreeBSD and the Mac OS, only these 4 functions are supported. All these 5 functions, it is all not supported in all the Unix flavors. That is what we are demonstrating here. The next function is set jump and the long jump. What is this set jump and the long jump function is? In order to understand this, we know already a goto function. The goto functions that you have seen, goto label, in so many other programming languages, we don't want to use those goto functions. That facility is not there. Here what we do is we use the function call. From one location to the other locations we go. If we do that, whenever you check the memory layout, it takes so much amount of space. If you check the memory, so much amount of space is allocated in order to store the stack frame. I think you have heard the word stack frame. The stack frame is nothing but the entire content of the stack of that function that will be stored in so many locations. That entire set we call it as a stack frame. That stack frame, like this. See, in the memory, the stack frame for the main, stack frame for another function. This assume that this is a main function, do underscore line is another function, command underscore add is another function. So much of space in the memory is being allocated for to store the entire content of the stack of this function. 3 functions are there, 3 stack frames. If there are 10 functions, 10 stack frames. Stack frame is the thing, but the content of the stack to related to this one function. The return address, the calling address, all those informations, it will be stored in the stack. That we discuss with the example. We discussed that with the example. Without the set jump and long jump, what happens after using the set jump and the long jump, how the memory allocated for that it is going to reduce, that we will discuss in the uh, next class. Thank you.